Okay, join me on page 286 in your science textbook. Follow along. How are the main layers of Earth subdivided? There are two types of crust, continental crust and oceanic crust. Continental crust makes up Earth's land, while oceanic crust is the floor of the ocean. Continental crust, made mostly of a relatively lightweight kind of rock called granite, is thicker and less dense than oceanic crust. Continental crust has an average thickness of about 32 kilometers, or 20 miles. Oceanic crust is made mostly of basalt, a denser rock than granite. The thickness of the oceanic crust averages about 6 or 7 kilometers, or 4 or 5 miles. The mantle is divided into two parts, the upper mantle and the lower mantle. Both continental crust and oceanic crust form the lithosphere. The lithosphere is the rigid outer part of Earth made up of rocks in the crust attached to the upper part of the mantle. The name comes from the Greek word lithos, meaning stone. The lithosphere is broken up into plates that move slowly. These plates are also called lithospheric plates. Okay, continuing on page 287, mantle. Because of intense heat and pressure, mantle rocks below the lithosphere are semi-molten or almost melted. These rocks can actually flow, bend, stretch, and compress. They make up the anosphere, the layer of semi-molten mantle rock that lies directly below the lithosphere. The name of this layer comes from the Greek word athenos, meaning weak. These rocks are not as strong and solid as the rocks closer to Earth's surface. The lithospheric plates float on the asthenosphere. They are supported and moved around by the movements of the rocks of the asthenosphere, in which the same way that logs are carried and moved around by currents in a river. Magma. Magma is molten or melted rock deep below the surface of Earth. Its temperature is between 650 degrees Celsius and 1,200 degrees Celsius, or 1,202 degrees Fahrenheit and 2,192 degrees Fahrenheit. Magma forms only under specific conditions in Earth's asthenosphere. Magma forms when heat melts parts of the mantle and lower crust. Because it is much hotter and less dense than surrounding rock, magma rises toward the surface. Magma is often found in magma chambers under Earth's surface, below volcanoes. When volcanoes erupt, magma can surface as rock or as lava, the surface form of magma. When magma reaches the surface, it cools and solidifies over time and crystallizes into igneous rock. Okay, turning the page to page 288, follow along. What moves the plates? Scientists do not fully understand what causes Earth's plates to move. Most agree that it is caused by movements in the rock in the part of the mantle that lies below the plates, a process called convective flow. Convective flow is the continuous circular pattern of materials as they are heated and cooled. And this is this picture that on your screen is convective flow, Okay, continuing in your science textbook. Warm matter rises and cool matter sinks. This principle is true of solids, of liquids, and of gases. Think about a pot of boiling water. When the pot of water is heated, the warmer water rises to the surface. In this example, warmer water is less dense than cooler water. When the water molecules reach the surface, they begin to cool slightly and move sideways across the surface. As they cool more, molecules grow closer together, so their density increases. Once they become just a little cooler and denser, they sink back to the bottom of the pot to be heated again. This is only one example of convective flow. So you can see that picture in your textbook. The heat rises, and as it rises, it's further away from the heating source, so it cools again, and then comes down because it's denser, and then gets closer to the heating source, so it begins to rise again. Okay, continuing on page 289. Convective flow in the mantle. Convective flow in Earth's mantle occurs in almost the same way as it does in water. Hotter, less dense rock at the bottom of the mantle rises toward the bottom of the plates. As it rises, it becomes cooler and denser, and it moves sideways. In time, it becomes cool enough and dense enough to move downward. As the rock descends, it becomes hotter and less dense, and it rises once more. This circular pattern of movement is repeated over and over. The convective flow in the mantle takes place much more slowly than it does in a pot of boiling water. As the moving rock in the mantle comes up below the rigid plates and moves sideways, the plates above it move as well. Because convective flow is slow, the movement of plates along their boundaries is also slow. And we know that from previous studies that the movement is very slow. All right, thanks again for following along, and I'll see you on the next one.